Unit 8, number 3, more operations in scientific notation. Really, it's just addition and subtraction as well. So, number 1, will the method for multiplying and dividing numbers in scientific notation work for adding and subtracting numbers in scientific notation?
The standard form.
No, because the standard forms, that doesn't have to make a lot of sense right now, but it will. Okay. The standard forms and also the base 10 values, you can't add bases. There's no exponent rules for adding same bases, or really even different bases. You'd have to change it into standard form before you add or subtract, which is what we're going to be doing today. Now, they're going to show you a rule. You can remember that rule, but I will not be. And I will not be teaching you the rule, but I will show it to you. Alright, so on at these. Alright, so on this first one, we got 5 mil plus 2 mil. Well, not plus, but we could rewrite these. So this would be 5 times 10 to the power of 6. 2 mil would be 2 times 10 to the power of 6. So on at these, let's say that we were going to add at these. I'm sorry, it says subtract on the next problem. We'll look at that. Alright, test the method you learned above to see if it works for subtraction. Did it tell us to add? Alright, we're going to subtract at these. Alright, what we can do on at these if we're subtracting. Alright, if we subtracted these, then we would have 3 times 10 to the power of 6. Now, that doesn't have to make a lot of sense right now. Here's why. Because if we come back up in here to those numbers that we wrote up at the top, and we said we're going to subtract these. Well, let's not look at the scientific notation. Let's look at the standard form numbers right there. Well, 0 minus 0 is 0, and 0 minus 0 is 0. It's got a lot of zeros. But then we got 5 minus 2, which is 3. So this would be 3 millions.
Oh, that makes sense. That's easy. I get it. I already got it. I did that problem.
Alright, now this one just happened to work because the exponents of the base 10s were the same. Now, if you're going to use that method, that's okay, but the base 10s have to have the same exponents every time before you add and subtract. That is why we don't do it, because sometimes you're like, sometimes you guys will be telling yourself, I need to move the decimal to the right, and so I'm going to change the exponent, but the wrong way. Okay. That is why, from now on, when we do these, we're going to be doing the operations only in standard form, and not worry about this rule, because when you guys see stuff in standard form, you're pretty good. Pretty good. Write in your own words how to add or subtract numbers in scientific notation that have the same exponent or order of magnitude. Alright, so we would add or subtract the decimal and keep the base 10 and its power. But again, we're not so concerned about that method. So in actuality, we're going to be changing these into standard form, doing the operation, and then changing it back into scientific notation. So number 5, find each sum or difference. We'll write our answer in scientific notation. It's going to be so fun. Alright, so this first one, I'm going to change that 3.45 times 10 to the third into standard form. So that'd be 3,450. And we're going to add this number, which would be 6,110, which would give us 9,560. But it wants the answer in scientific notation. So we're going to change this to 9.56 times 10 to the power of a 3. So that's where I want 1, 2, 3 times. Alright, good luck.
Okay. First, we have to expand both sides. So that would be 8, 9, 6.
It's the 6.
And then minus 3, 4, 1. And that would equal, obviously, 5, 5, 5. And then to put it in scientific notation, we just do 5.55 times 10 to the power of 7.
That's correct. All right, on at these. That 10 to the power 0 tells us we're going to move the decimal 0 times. So that gives us 6.43. And we're going to add at these to 4.39er. And that would be a 12, carry the 1, we got an 8, and a 10, right account. Bam. But this is not scientific notation. So we're going to make this 1.082, meaning we took that big number and made it smaller. So I got to make the power of 10.
Plus 1?
Well, yeah, you can just make it 1.
I got it right.
You don't need to show that 1 if you don't want to. You can make it a phantom 1, but that is all. So before, this was 10 times 10.82. It would have been times 10 to the power of 0. And since we moved the decimal over 1, we would have added 1 right account. And that gives us the power of 1. There we go!
Yo, is this for YouTube? Yeah. Yo, what's up, YouTube? Okay, so we're gonna simplify the numbers, which is 0.000123 plus, on the bottom, wait, hold on. Is there like an undo button? There. Hold on. Hey. That's 0.000804. And then if we add those together, let's add those, you get a total of 729,000.0. That's a small number. That's the answer, right, Mr. Snow?
Alright, that is the standard form.
And then we gotta wait, can I change it?
Yeah, go ahead.
Let's go. So we're gonna move the decimal, 1, 2, 3, 4 places to the right. That gives us, 1, 2, 3. That's 9.27 times 10. Let's undo that. Times 10 to the 4th. Negative 4th. Excuse me.
Correct.
Boom, easy.
Excellent work.
What? Wants to follow her dream of being a YouTuber.
Okay, so what you would do is you would make them in standard form to be 4.
That's a lot of zeros.
And there's one more right there. And then you would go, yeah. Yeah, I think that's 11. And then you would subtract that. And then would that be the 11th?
That is correct.
Oh.
Excellent work. I'll just show that over there. Alright, good luck.
Okay, I'm not doing it your way because you take too long. Okay, so I'm going to do 6. Holy crap, that's weird. 0.1 minus 3.2. And that is 2.9. And then, so you have the quotient of those two, so it's 2.9. And you do 10 to the negative 8th power.
That is correct. Now again, this
That's
is
the quickest
good to
way.
see because you can use the rule, but on the next side of this worksheet, you must be very careful.
But I am able.
You might be wondering what to do if numbers do not have the same order of magnitude. Write down your ideas of how you might be able to add or subtract these numbers. Be ready to share your ideas with the class. So we can change the numbers to standard form, operate, change the answer to scientific notation, bam. 3 quick, easy steps. Alright, so you could follow these steps and change everything so that all the base 10s have the same power. However, you open yourself to a lot of mistakes that way, so we try to avoid it. There was another method, it's called calculator, but we'll skip that one. We're going to try these out, then we're going to find the sum or difference. And our answers will be in scientific notation. Alright, so I'll do this first one. So our first number, radical, that's going to be 4, 1, 2, and then 5 zeros.
This is going to be
4, that's, yeah, 4 is what I meant. Let's take it out.
Mr. Sal. Or
It doesn't matter, it's all good. 4,120,000. And radical, we're going to add that to 394 and 2 zeros. So I'm going to line these up on purpose, like these. And when I add them now, I got 0 plus 0 is 0, plus 0 is 0, and 0 plus 4 is 4, and 0 plus 9 is 9, and 2 plus 3 is 5. Then we got a 1 and a 4.
Mine.
Alright, so on this one, I got 4.1594 times 10 to the power of 1, 2, 3, 4, 5, 6. Bam.
Mr. Sal, do you like the color of the sky?
Alright, this next one, once again, we're going to change these into standard form. So I got 4, 2, 3, 0. And now I got subtract. This one, after we move that decimal, is just 956. So we're going to subtract these. 0 minus 6 is 4, because I got to carry the 1, and I got to carry this one as well. Then I got to carry 1 from right count. 12 minus 5 is 7. Yeah, I know you guys could do that in your calculator, but either way, 3,274 is the standard form answer, but that's not what we want. We want scientific notation. 3.274. And then this would be multiplied by 10 to the power of 1, 2, 3. Thank you.
Okay. So I guess I'll say I simplified this right here, which is 0.0034. Then this, which is 0.0457, and then you add those together. So, and then that would equal 0.04891, and then you change and they change this into scientific notation. So you move that twice, which would be 4.891 times 10 to the power of -2. Yeah.
I was trying to subtract them.
Alright. Thank you. Alright, now when we add, and this is why it's good to see this, especially with decimals, is we should always start with the place values farthest to the right on that, right? Alright, so what that means is we got to change some of this. Alright, so we got the 0 point some stuff. 4 plus 7 is 11, right? So we got to carry the 1 right there.
No, I wrote it. I don't even know why I did.
Yeah, no, that's okay. So yeah, and like your calculator says, 0.0491, which would be 4.91 times 10 to the power of -2. There we go. So that's very small. I mean, like you've shown with your calculator, that's something you could fix very easy. So, very good. So right, I count. We got subtraction. So I'm going to have 3,670, and we're going to subtract from these. That appears that it would be 0.16. So I'm going to need a decimal on that 3,670. And by subtraction, I got to borrow 1 radical, so I'll make that a 9, borrow from radical, which means we got to borrow back up and count. And I got 10 minus the 6, which is 4. 9 minus 1 is 8. 9 minus 0 is 0. 6, 6, 3. Yeah, that's a very...
9 minus 0.
Thank you. 3,669er, 0.84. But this in scientific notation would be 3.66984 times 10 to the power, and we moved it 1, 2, 3 times to the power 3. Nailed it. E, this one would be 0.1234841, and we're subtraction. This would be 0.1234579er. Now to subtraction, we gotta borrow one from a these, and we're gonna have to borrow one from a these. 11 minus 9 is 2, 13 minus 7, 6, 7 minus 0 is 7, then we got all these zeros up in here. So this is my final answer in standard form, but we want scientific notation. 7.62 times 10 to the power of 1, 2, 3, 4, 5. And that's a negative 5 because we made that small number bigger. There it is. All right, good luck.
Okay, first we have to make this normal. 0, 6, 9, then plus 240, and that leaves us with an answer of 240. 0.0691, which when we put it into scientific notation is 2.400691 times 10 to the power of 1, 2.
Correct. Excellent work. The Earth, and yeah, we're going to use scientific notation where we can. The Earth is 9.3 times 7 to the, 10 to the power of 7 miles from the Sun. Pluto is quite a ways more from the Sun. How far is it to Pluto from Earth? All right. Well, we can see how far away they are from the Sun. So if we take Pluto's distance, 3.67 times 10 to the power of 9, and we subtract the distance the Earth is to the Sun, then we will have the distance from Pluto to the Earth. So that is 9.3 times 10 to the power of 7. Now again, we like to subtract using standard notation. So we should change these. So I got 3, 6, 7, and 7 zeros. Yeah, so this is a pretty big number, and some of you guys' calculators may not fit it, which means that you may have to change it into scientific notation, which is okay. Now we're going to subtract these, 9.3 times 10 to the 7th. And yes, once again, I'm lining those up on purpose, my place values, so that when I subtraction, we can see the place value is pretty easy up and count. So 1, 5. 7, 5, 3. So we can see, it appears, that the distance from Earth to Pluto is approximately 3,577,000,000 miles. But just in case it does want it in scientific notation, 3.577 times 10 to the power 9er. Also, don't forget to label that in miles. All right, pretend a new planet has been found in the far reaches of the universe. You know the Earth is 9.3 times 10 to the power of 7 miles because it was just in that last problem from the Sun. But the planet we're interested in, or we're pretending to be interested in, is 7.3 times 10 to the power of 12 miles beyond the sun in the opposite direction of the Earth. So what is the distance to the planet from the Earth? So let's draw a picture on it, these, so that it helps us. So this one is one of those dark suns, one of those black ones, like a black hole sun. All right, now here's the thing though, is let's say that this is Earth right there. Now that looks like it's pretty close, but in actuality, in comparison to the other planet would be like way over here. It'd be even farther away than that, actually.
Oh, I can't even see it.
This would be the other planet right there. Now, that's the distance it is from the sun for both of these, so we're going to have to add the two values. Alright, as it turns out, we can see on it these, that we got to take the distance from the Earth to the sun, and we got to add this distance from the sun to the planet. By the count. That will tell us the distance from the Earth to the planet. So let's look at it these. So I got the distance from Earth. We already shown that was 93 million. And we're going to add the distance from the planet to the sun.
Which is
Alright, to me it looks like this is, looks like that is 7.3 trillion miles. So when we added these, it will tell us the distance the planets are from each other. So that's a 7300093.
look, it's like that.
1, 2, 3, 4, 5, 6.
Oh my gosh, that's
Bam. Now that's a pretty big number.
it is a pretty big. Why is that number so big?
Let's change this into scientific notation. 7.3 times 10 to the power of 12. Alright, so you guys are concerned. Alright, so some of you guys are concerned about why we don't include that 93 million. That is because it's insignificant in comparison to the 7.3 trillion. It's so small in that comparison that, and we talked about this before, scientists say that we don't even care about that 93 million, even though it's 93 million miles. Using the distance you found above and the fact that light travels at 5.88 times 10 to the power of 12 miles in 1 light year, determine how many light years it will take for light to travel to this planet from Earth. Alright, so the distance that we have was 7.3 times 10 to the 12th in miles. And since we want to know how many light years it is, we're going to divide that by how much a light year is. 5.88
1 1/2
times 10 to the power of
1.5
12 in miles. This will tell us how many light years it will take. Alright, so we got 1.42 times 10 to the power of 0. So we could just say 1.42 light years.